Welcome to class today, students. My name is Ms. Tessler. Today, we'll be identifying, defining, and drawing perpendicular lines. Now, what are those? I can't wait for us to discover together. Here's what you'll need for class today. Pause the video, gather your materials. I'll meet you right back here. Get your straight edge ready and follow along with me. Pause the video whenever you need to stop and work. First, you'll draw 3 line segments positioned like mine. Line segment AB, line segment CD, and line segment EF. Then, estimate halfway up line segment AB. Draw point X there. Then, estimate halfway up line segment CD. Draw point Y there. Now, draw horizontal line segment XY. Tell me what word you see when you do that. Hello to you too. Now you can erase line segment XY. We'll do one more. Can you draw line segment CF? Tell me what word you see then. Yeah, that's right, it says in. Now let's get in to today's lesson. Tell me what you notice about my drawing. Yeah, you may have noticed that I drew 2 line segments, or that they make 4 right angles. I'm going to label some of the points. Line segments AE and ED make a right angle. What are some other pairs of line segments that make a right angle? Here are some other pairs that form right angles. Do you see the one that you found? Remember, we can name these in multiple ways. So if you said EA or DE, for example, you would still be correct. Now, we have a special name for these lines that make right angles. Yes, we call them perpendicular. Can you say that after me? Perpendicular. Very nice. So these 2 line segments I drew, AC and BD, are perpendicular. And that's the symbol that we use when lines are perpendicular. Now this says line segment AC is perpendicular to line segment BD. Take a moment to think, then tell me, do any of the letters in the word math have perpendicular lines? 3 of them do. You might have noticed that the lines in the letter T are perpendicular. They form right angles. You might also have noticed that the lines in the letter H are perpendicular. They form right angles too. The third one is kind of tricky. Do you see it? These 2 lines here in the letter M are perpendicular. Even though they're diagonal, they form a right angle too. What about the others? Let's check. These two lines make an angle smaller than a right angle. That angle is acute. So these lines are intersecting, but they're not perpendicular. In the letter A, this angle is acute. This angle is acute. And this angle is obtuse. So these lines all intersect, but they are not perpendicular either. Now I wonder, what other letters have perpendicular lines? Maybe you have some in your name. All right, now that we have a definition of perpendicular, let's identify some perpendicular lines. Hold up your right angle tool and trace that right angle with your finger. How can we use this to find perpendicular lines? I think the red and blue lines on my lined paper are perpendicular. Let's use this to check. Yes, these lines are perpendicular because they make a right angle. Now, it's time for us to go on a little math adventure. Wherever you are, how many perpendicular lines can you find this way in 3 minutes? Use a timer if you have one, and remember to say the word perpendicular when you find them. Pause the video, then come back and show me what you found. I can't wait to see it. I'll race you. Hey, welcome back. I found a ton of perpendicular lines around my house. Tell me about what you found. Wow, very nice. Here are 3 of the things that I found. Ooh, check it out. The edges of my floorboards are perpendicular to each other. This design on my door is made of perpendicular lines. And what holds up these shelves? You guessed it, perpendicular lines. Now that we can define perpendicular and identify examples of perpendicular lines, it's time to draw them ourselves. Earlier, we looked at vertical and horizontal line segments, but a line could go in any direction. So I'm going to draw a diagonal line segment. This is line segment JT. I can use my right angle tool to draw a line that's perpendicular to line segment JT, even if it's diagonal. Watch this. There we go. Now, how do we know it's perpendicular? You did watch me use the right angle tool, but if I turn the paper like this until line segment JT looks horizontal, it might feel easier to tell. Now it's your turn to try drawing your own pair of perpendicular lines. Pause the video here and use your straight edge and your right angle tool. Can you label and use the symbol to describe your line segments too? Wow, you learned a whole new way to think about lines today. Awesome job. I think you're ready for the problem set.
I'm Mrs. Gradney, and today in our lesson, we'll be learning what parallel lines are, and we'll even be drawing some. Here's what you'll need for our lesson today. Let's get started. I have 2 straight edges here. Watch how I position them. Now, are the two straight edges touching? No, they're not touching. Imagine these two straight edges like roads that you could travel on in either direction forever. Would the roads ever intersect? No, they would never intersect. How would you describe how these two straight edges are lined up? Pause the video to think about it and describe it. Maybe you said the two straight edges are perfectly lined up. Or maybe you said they're side by side and they're not touching. Or maybe you thought about what they're not. Maybe you said they're not perpendicular because they're not making any right angles. They're not making any angles, in fact, because they're not touching. They'll never touch, no matter how far we extend them in either direction. What you've just described are called parallel lines. Everyone say parallel. Two lines that will never intersect, no matter how far we extend them, are called parallel lines. Pause the video and look around where you're sitting and see if you can find things with parallel lines. Then come back and share them with me. So, what did you find with parallel lines? Wow, you all had some great ideas, and I found some of the same things that you did. I noticed the opposite sides on my whiteboard are parallel. The shelves on my bookshelf are parallel. Even the lines between the bricks on my floor are parallel. Parallel lines are all around us. Take a look at the letter N. Are there any line segments in this letter that appear to be parallel? Hopefully you noticed this line segment and this line segment look like they're parallel. And we can mark that, we can show that they're parallel using a symbol like this. We can draw an arrowhead on each one to show that these two line segments are parallel. What about these two line segments? Parallel or not parallel? Pause the video to explain what you're thinking, and be sure to use the word parallel as you're explaining. Did you say these two line segments are not parallel? If so, you're correct. Even though we can't actually see these two line segments intersect, we can kind of picture that if we were to extend them both in this direction, they would intersect somewhere over here. I can show that using my straight edges. If I line up one straight edge with one line segment and my other straight edge with the other one, it makes it even more clear that they're going to intersect somewhere over here. So these two line segments are not parallel. Let's try another one. Parallel or not parallel? Well, these two segments certainly appear to be parallel, don't they? It doesn't look like they would intersect if we extended them in either direction. Do you remember the symbol that we can use to show that these two segments are parallel? Right, we can draw an arrowhead on each. Great, let's try one more. Parallel or not parallel? Not parallel. With these two line segments, we can clearly see that they would intersect if we just extended this one just a little bit, huh? Nice work. Now I'm going to take my two straight edges and I'm going to make them parallel again. What do you notice? Pause the video and use the word parallel in a sentence that describes your observations. I heard someone say that parallel lines look like train tracks. They sure do. Someone else said parallel lines are side by side without touching. Another friend said parallel lines are the same distance apart at every point, so they'll never touch. All of those are great ideas. So, with your description of parallel lines fresh in your mind, tell me, are these two line segments parallel? You probably said yes, they are parallel. And I agree, they certainly look like they're parallel. But so that we can be sure and so that we can be precise, we can actually measure using our right angle template. Watch. To measure to see if two line segments are actually parallel, first, we place a straight edge perpendicular across the two line segments. Then we take our right angle template, line up one side with the straight edge, and we line up the other side with one of the line segments. We line it up perfectly. Right now, that's not really lined up correctly. So I'm going to turn it a little bit. There we go. Now it's lined up perfectly. Now we'll slide the right angle template up and see if it also aligns perfectly with the other line segment. If it does, then the two line segments are parallel. So let's try it. Slide up. Does the right angle template also align perfectly with the other line segment? It sure does. So are these two segments parallel? They are parallel. And do you remember the symbol we can use to mark to show that they're parallel? Right, we can draw an arrowhead on each one. Great job. Now grab your grid paper, and we're going to use our straight edge to draw a rectangle. To start, pick any corner, it doesn't matter where you start, and draw a point and label it A. Now, to draw our first side for our rectangle, we're first going to draw point B, and then we're going to connect points A and B. So to draw point B, we're going to start at A, and we're going to move over 3 columns and up 1 row. Okay, so ready? Let's do that. Starting at A, over 3 columns, 1, 2, 3, and up 1 row. Now draw a point there and label that point B. Now if we use our straight edge to connect these 2 points, we have the first side to our rectangle. Now for the next side, we're first going to draw point C. To draw point C, we're going to start at point B. We're going to go down 6 rows and over 2 columns. Okay, ready? Let's go down 6 rows. 1, 2, 3, 4, 5, 6, and over 2 columns. 1, 2. Let's draw a point there and label it point C. Now, if we connect points B and C using our straight edge, we have the second side to our rectangle. Now we're going to draw point D and connect points C and D to make the third side to our rectangle. To draw point D, just like over here, to draw this side, we went over 3 and up 1. We're going to go over 3 columns and down 1 row. Okay, ready? So starting at point C, 1, 2, 3, and down 1 row. There we go. Draw a point there and label it point D. Now if we connect points C and D, there's the third side to our rectangle. And now how do you think we're going to get the fourth side to our rectangle? Right, we're going to connect points A and D. So let's do that. And we have our rectangle. Now, in your rectangle, find segment AB. Trace it with your finger. Here's segment AB. Do you see another segment in the rectangle that looks like it would be parallel to segment AB? It kind of looks like segment CD is parallel to segment AB, doesn't it? And we can mark that they're parallel using our arrowhead symbol. Now, to be sure though, let's check to make sure they're parallel using our right angle template. Do you remember what to do? We'll place our straight edge perpendicular across the 2 line segments and then line up our right angle template, one edge with the straight edge and the other side, line it up perfectly with one of the segments. And then we'll slide our right angle template up and see if it also aligns perfectly with the other segment. Let's do it. Does it also line up perfectly with the other line segment? It sure does. So segment AB and segment CD are parallel. We can record that they're parallel like this. Segment AB is parallel to segment CD. This symbol here, just two lines, two straight lines drawn close together, means is parallel to. Do you see any other line segments in the rectangle that look like they're parallel? Pause the video and find another set of parallel sides in the rectangle and record that they're parallel using symbols like I did here. Then come back and check your work with mine. Welcome back. Check your work with mine. Let's read the statement. Segment AD is parallel to segment BC. Did you notice when I used the arrowhead symbols on the rectangle this time that I drew two arrowheads on each segment? Why do you think I did that? This time I drew two arrowheads on each segment because if I only drew one on each, it would seem like these two segments are parallel to these two segments, which we know they aren't. How do you think we would mark it if we had another pair of parallel sides? We draw three arrowheads on each. Great job. Now take a look at our rectangle. What do you notice about the sides of the rectangle in parallel lines? We can see the opposite sides of the rectangle are parallel. But do you think that's true about all rectangles? Let's do some exploring and see if we can figure it out. Pause the video, draw at least 3 different rectangles, and then use your right angle template to check for parallel segments. Then come back and we'll discuss. So what did you discover? I found that for all the rectangles I drew, the opposite sides were parallel. So then, does the length of the opposite sides of a rectangle change the fact that they're parallel? No, the length of the sides doesn't matter. These short sides are parallel, just like these longer sides are parallel. Opposite sides of all rectangles are parallel. Excellent work today, friends. I think we're ready for the problem set. On the screen are the must-do problems for the problem set. Work on these problems for 10 minutes, and if you have extra time, feel free to try any of the other problems on the problem set.